The issue to be addressed is how to find simple and fast solutions to keep the knowledge of train drivers and face ever-changing specifications. When an ERTMS signaling project is undertaken, there are several steps within the project dealing with complex matters such as baseline, system version, with the need to collect track data, develop engineering rules, and design operational scenarios. One of the last steps in the process is the training of the drivers. But what happens if there are changes, for example, due to a new version of the specification? This will mean a new project and probably changes such as new track data, new operational rules, etc., and a need for new training. The need will be to ensure that the data and knowledge acquired are not lost, that the changes due to the new projects can be introduced quickly, and that the tools and processes can be reused. And moreover, in a context where the environment is changing due to the TSI, the technical specification for interoperability. As you may know, the ERTMS ETCS system is very complex. 4 baselines have been introduced so far, with 5 system versions. Interoperability is a demand with backwards compatibility as well for the onboard systems. This is quite complex. The users need to get and keep their knowledge. Signaling engineers will design the tracks and the operational rules. Drivers will operate the trains.
An efficient training can be achieved with the use of reliable and accurate simulation tools and proper data collected from industrial projects implemented in scenario, also called use cases. This will be explained in detail in the next slides. Our solution is simple, based on a laptop. The use cases or scenarios are created manually, track data, train data, and so on, and stored in the database. This is called the offline procedure. In the online procedure, the operator selects a scenario to be run in a real time. The ETCS GMI will be shown with other useful information to enable the train movement. A 3D can be interfaced through an additional PC. Training is used for nominal use cases or degraded cases. Nominal cases are simple to reproduce and simple tools can be used. Documents and on-site training can be sufficient. However, for degraded situations, such as failure and incidents, this can hardly be done in a train. Therefore, simulation is adequate for such use cases. For new functions, simulation is also appropriate.
Nominal situations are, for instance, starting a train movement, starting a shunting movement, transmitting movement authorities by radio, loop, or balise group, performing an ETCS level transition. The operating mode, which is the nominal mode, is FS, meaning full supervision. Degraded situations are those resulting from failures and incidents, such as, for instance, the loss of radio communication in ETCS level 2, or the failure of a critical component within the onboard architecture. We are going to show you the first scenario, which describes a nominal situation, such as starting a train movement in ETCS level 1, is also called SOM. And in this, this will be a video in which we will explain you the different areas of the simulator, and these explanations will be useful throughout this total seminar, webinar. As you can see, the screen is divided in 3 parts. On the left side in the center, you have the ETCS DMI, which currently is off. On the left side, you have a small driver's desk with a traction brake handle. And on the top, you have a track view where the train is located on the left side. And it's not a train moving, but it's a landscape moving inside the train. So we have at the moment the start of mission procedure going on with entry of driver ID, entry of ETCS level, the entry of train data, as you can see, asking for train movement. And the train will go to staff responsible mode, and the driver will be allowed to move the train at a certain low speed, as you can see. We will approach a group of balises at a signal, and these balises are transmitting a movement authority, which is transmitted to the train. And here you can see the DMI itself. In the center, you have the current speed and the permitted speed. On the right side, you have what is called the planning area, where you can see the restriction and the end of movement authority, including also gradient information and track conditions. So at the moment, we are approaching the target. And you see the remaining distance to this target, which is about 100 meters, and which is decreasing. So this is a target which is supervised at a speed of 80 kilometers per hour. Now we are at the second target, which is the speed zero speed at the end of authority, and we are approaching. You see a yellow bar, which indicates that we are changing the supervision mode. We go to target speed monitoring, and the speed is the speed to reach is 0, and we can approach with a release speed. You see the value of 20 kilometers per hour. So this is typically a nominal situation. This the next slide shows you an example of degraded use case, and it will be we are approaching an end of movement authority with a need to press the override button. Here we are starting in the same way as previously, except that instead of being ETCS level 1, it is ETCS level 2. We received the movement authority quite quickly at the beginning, and we see that we are running the train. It's a little bit fast. We are approaching the end of authority. You see this in the planning area, this yellow indication bar, meaning that we go to target monitoring, and we are approaching the end of authority. And here we have something happening is that we lost radio connection. So the driver has to stop the train. He asks permission to activate the override function. And when he gets the permission, he will push a certain button, which is the override button. You see here, it's a button named EUA, end of authority. Now we switch to override mode, which means that the train is able to pass beyond the end of authority. And it's a specific under mode of the staff responsible mode. And we approach the end of authority, but we are allowed to drive with a maximum speed of 30 kilometers per hour. And you will see that when we pass the end of authority, which is happening quite soon, this icons for override is moving away. And we have again the staff responsible mode. So remain in staff responsible mode for the moment because we have no radio connection. And you see now the radio connection is re-established, which means that the connection is again available, and the RBC will send a new movements authority to the, as you can see here. So we have switched from a degraded situation to a nominal situation again. Now we are going to show you another example, and this is for train drivers and signaling engineers. We will show you the braking curves in parallel to the DMI to enable an understanding of the principles, because there are some common parts to between what the driver has to see on the DMI and what is happening in the braking curves. So this will be explained more in detail in the video. Here you see the video. So we have now 5 areas. We show you on the right side at the top, we show you a picture of the braking curves with the distance traveled versus speed. And at the bottom of this, you see numerical values. The slide is a bit complex. It will be the most complex, but it's only, we show it only to explain you the braking curves. So we run in staff responsible for the moment. And now we switch to full supervision. And this is a little bit for experts, but you see that you have a target of 100 km/h and a second target, which is 0 speed. And you see that the system is changing the target speed, which is supervised. Here we are going to reach the target of 100. And so for the moment, 100 is the target which is supervised. And now we switch to the new target. And you see at the end, you see a curve which is called the EBD, and another curve which is the SBD. And you see also a calculation of a release speed. You see again this yellow bar. You see it's the same. The yellow bar is also a bar on the left side, on the right side, sorry. And when you pass this yellow bar, you're entering in the supervision limits, and you also see this permitted speed which goes down, and you see a release speed of 40 km/h. So we are able to show in parallel DMI and the braking curves.
This slide is for showing how the system version is managed. You have to know that 2 system version is available within Baseline 3. We have system version 2.0 and system version 2.1. And for both versions, there are different behavior when approaching a restrictive target. It is not obvious to see immediately in which system version the ETCS on board is operating. For system version 2.0, the planning area can be switched off or on by the driver by clicking on the button on the top right corner of the planning area. The operating system version is shown on the GMI when clicking the system version button available on the GMI settings menu. For system version 2.1, the operating system version is shown on the GMI when clicking the system version button available on the GMI settings menu. We can also notice that the planning area cannot be switched off by the driver.
The next scenario is about a side effect introduced in system version 2.1, also named 360. The main point is the transition between sailing speed monitoring, CSM, and target speed monitoring, TSM. And this happens when the yellow bar is passed. In system version 2.1, the yellow bar represents the indication, which is at a variable distance in rear of the next target, depending on the current train speed and acceleration. In system version 2.0, the yellow bar represents the pre-indication, which is at a fixed distance in rear of the next target. So we are going to show you the effect of the falling hook in a video. So this is the example of the falling hook. We are in system version 2.1. We are in level 2, full supervision. You see the target, which is at 100 km per hour. And when we pass this speed, we are moving to this target. You have seen here there was a jump from 200 to 140. And this is the falling hook phenomenon, which is a very big jump from a high speed to a lower speed. And now we do the same with the system version 2.0. You will see that we don't have this jumping effect. We transmit the same track data, but you can see that the target speed is shown on the DMI, and the permitted speed is always decreasing. So you don't have this this jumping effect of the permitted speed, because you see smoothly the permitted speed, which is reduced up to the new target speed of 100 km per hour. So no jumping effect in system version 2.0. And this is something which was very strange to the drivers when they had to switch from 2.0 to 2.1 in some projects.
Yes, this slide is for showing the most relevant display target and explain it. The scenario you are going to see will show which target is the most relevant one among all of those supervised. The train is running in full supervision mode with two supervised targets at 100 kilometers per hour and 0 kilometers per hour for the end of authority. At the beginning, the MRDT is the end of authority. But when the train speeds exceed 100 kilometers per hour, the target is changing. We can see in the planning area that the yellow bar is moving down since the train is approaching the target. When we will brake until the train speed is below 100 kilometers per hour again, we can see that the MRDT is again the end of authority. To summarize, the ETCS system can receive several constraints at the same time. To avoid overloading the driver, the GMI displays only one as the primary reference, the ones that has the most immediate impact on driving. In this slide, we are going to explain the non-protected level crossing when you are going to pass this kind of track data. This scenario shows a new feature. This new feature is introduced in Baseline 3. And the situation is to explain how to approach such a level crossing and the resulting supervision. The train starts in staff responsible mode level 1. It receives the first movement authority when passing the first balise group. The next passing balise group will announce an unprotected level crossing with an order to stop in rear of the level crossing area. The onboard system calculates a braking curve to force the driver to stop in rear of the level crossing. Once the train stops, the movement authority is extended beyond the level crossing area and allows the train to pass the level crossing at the speed limit of 30 kilometers per hour. And after having passed the level crossing, the train will be able to run fast again. We can see in the planning area that the next target speed will be 150 km per hour. This scenario shows two track conditions, non-stopping area and area with powerless section, where the pantograph shall be controlled. The non-stopping area is explained firstly in the next video. The train starts in staff responsible mode. The pass balance group is sending two track conditions which are announced in the planning area. The first is dealing with an area where the train is not allowed to stop. The onboard calculates whether the train is able to stop within this area. This area is firstly announced with a yellow icon. When the train is inside the area, a gray icon is shown. From the moment the train cannot stop within the area, the symbol disappears. For the second area where the pantograph will be lowered, the driver is informed to lower the pantograph by displaying the lower pantograph announcement icon. Then, the lower pantograph icon is displayed when the train is in the area. The pantograph shall be lowered. Then, the raised pantograph icon is displayed to inform the driver that the train reached the end of area. The pantograph shall be raised. Here we have to explain stopping permitted in tunnels. This scenario shows a new feature introduced in Baseline 3. This scenario shows a specific track condition situation where it is allowed for the driver to stop in a tunnel. The train starts in staff responsible mode. The first passing balance group is sending the information about the stopping permitted in tunnels. The driver sees an icon informing that tunnel information is available. The driver presses and sees an announcement and distance to the start of this area. The train is approaching the area which starts at the entry of the tunnel. Later, the driver is informed of the start of the area when the GMI icon is switched from yellow to gray. And when the driver is no longer able to stop within the tunnel area, the GMI information disappears. This slide is for explaining the geographical position. This scenario shows a possibility for the driver to display the geographical position when this is transmitted by the track. The train location is based on distance traveled from ballast group. This information has no meaning for the driver. There, it is possible to transmit kilometer point information. The train is running in full supervision mode in level 2. The information related to the geographical position is received when passing the first ballast group. The driver sees an icon informing that geographic position information is available. The driver presses and sees the kilometer points in real time. We can display and hide the displayed kilometer points. 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 。 . 。 . 。 . 。 . 。 . . . 。 .
. . . . . .
When the track is no more able to transmit a kilometer point, or when the driver decides to remove the information, the kilometer point information disappears from the screen.
Let us summarize what the simulation activities are. First of all, you have to prepare the data, and this is done during the offline procedure. So the first step is to create, to edit a track. This is the first step. Second step is to create scenarios or use cases by defining train parameters and positioning all signaling elements and events. Signaling elements are, for example, where there will be a transmission by balises or loop or by radio, and events are, for example, incidents which can happen, for example, a loss of radio failure, for example. This is the offline. Then you have the online part, during which you execute scenarios. So the operator selects a scenario to play from a list. And then when the scenario is started, there is a real-time interaction of the operator, which is the driver, using the DMI and the desk of the operational simulator. And within the simulator, there is an ETCS onboard part, which is including all the functions of the ETCS onboard. So it's very accurate simulation. And during the scenario running, a lot of data are logged, and this log data can be analyzed in a later step. It's an option where we can, with a tool, display the different logs and understand the data exchanged. And this is used a bit for training, but it's also more used for testing. So what is offered by CLEARSY? CLEARSY has a complete solution combining tools, services, and training. So as far as tools are concerned, it's called the Operational ERTMS ETCS Simulator, and it is available for purchase or rental. The services which we can offer are creation, edition of scenario, and we can also make software extensions for specific needs, especially national needs, for example, STMs or national operational rules or transition to national system, etc. And another service is training. So we can give training courses to ERTMS ETCS, and we can give a training to the use of the operational simulator, either for instructors or for trainees, which are the train drivers. What are the benefits for simulation and return of investment? As you could see in our presentation and video, the first use is training. So the ERTMS ETCS beginners can learn very fast. A lot of operational simulation can be exposed, including a lot of degraded situations or new features. And the training is suitable for train drivers and signaling engineers, and specifically concerning the braking curves. So training is one use, but there is a second use of the simulator. It can be used for testing. And in this case, it's an accurate ETCS onboard simulation, which enables a test of components which can be connected. For example, onboard components like the ATO, automatic train operation, or trackside components like the RBC. And when you use our system for testing, there is a significant reduction of field testing. You can get more detailed about CLEARSY and its products. Concerning ERTMS ETCS matters, you can download different data sheets concerning the ERTMS tools, the operational simulator, which is a product presented in this webinar, and also a traffic simulator. If you have questions, you can contact us at the email address which is shown here. And you can also see us at two events. The ERTMS conference taking place in Valenciennes in April, and of course at the Inertrans exhibition taking place in Berlin, Germany at the end of September. We thank you for attending this webinar. And there will be a new webinar, next webinar about Baseline 4 in a few months.